Now, the definition of kinetic energy, potential energy, and mechanical energy is already, or you are all aware of from your smaller classes. The energy possessed by a body due to its motion, that is kinetic energy, its unit is joule. The same thing, the potential energy due to its position, and mechanical energy is the sum of the kinetic energy and the potential energy is called mechanical energy. Now, let us see conservation of mechanical energy in a free falling body. Wait a minute. Yes, we will see this. Suppose I have a situation like this. This is my weight. This is my height. The complete height is this. This is the point C, this is the point B, and this is the point A. The total height is H, and this much height is X. So here, when you just drop the body, just drop the body, the initial velocity has to be zero at A. At A. Let me write at A. Now, what would be, they see, there will be only potential energy at A and no kinetic energy. So that A at point at A, there will be potential energy is equal to mgh, but kinetic energy is equal to your zero, because initial velocity is zero. That's the point. Now, the total energy, total energy is total mechanical energy. I should use the word total mechanical energy. Wait a minute. Total energy or total mechanical energy. For short, I'm using total. Total mechanical energy. Mechanical energy is equal to kinetic energy plus potential energy. And this is nothing but mgh. Let me write it below. Wait a minute. This will be 0 plus mgh, and this is nothing but mgh. Now, at point B, at point B, at point B, at point B, B. See, it will come here with some velocity. There will be some velocity here, V. Let's find it out using the equation of motion. Let me draw a line here for you. Now at B, make mistake. Yes, just a minute. Yes, at B, we will have what you can see in the picture. We will have velocity as well as this much height is h minus x. This much height is x minus h minus x. So the potential energy at B would be simple mg h minus x. That's all. Now, what will be the kinetic energy? Kinetic energy is half mv square. I need to find this v at the point B. We will use the equation v square is equal to u square plus 2gh. This equation we will use. Already we know this equation from smaller classes also. And I've derived it in my earlier video also using the derivative method. So v square, u square is 0 square plus 2g, and this is how much distance it is, x. So this becomes v square is equal to 2gx. Just put the value here. So kinetic energy becomes half m into 2gx. So this becomes 2 cancels out. Kinetic energy comes out to be mgx. That's all. Now the total mechanical energy at this point. The total mechanical energy at this point. The total mechanical energy. Total mechanical energy. Total mechanical energy is kinetic energy plus potential energy. And this is equal to, here we have, and here we have mgx plus mgh minus x. Now when you open up the brackets, mgx plus mgh minus mgx, and this cancels out, you will get mgh. So you can see the potential energy, the total energy here is also the same, the total energy here is also the same. Now we will see something at point C, at point C. Let's see at point C. At point C, at C rather I should say. Let me draw another line for you here. Now at C, you can see in the figure, at C, there is no potential. There is no height. This is zero height. The height is zero here. So potential energy here is zero. Potential energy here is zero. Now the kinetic energy, see, kinetic energy is equal to half m v square. Now see one thing. Let me draw the picture here for you again. This was my C, this was my B, this was my A. This had initial velocity 0. The final, this had v square equal to 2gx. Right now I found out. Now this velocity which was at b will now become the initial velocity for c, for this one, this much portion. This will become, uh, now this will be u square will be equal to 2gx, and the height is already h minus x. I want to find the velocity here. Now I want to find the velocity v here. See, listen carefully. Already I had an initial velocity 0 at A. By the time it came to B, it has a velocity V. Now, whatever velocity was at B, that is this thing, will now convert into initial velocity for C. And now this will be, the final velocity here will be V. So writing the equation again, wait, writing the equation again, writing the equation again, see, we have V square equal to U square plus 2G h. This is our equation of motion. We'll use it. V square we don't know. U square will now become 2gx, and now my height will be this much height, 2gx height, 2gh minus x. This is the height right now. Now open up the brackets. 2gx plus 2gh minus 2gx will give me 2gh. So now my kinetic energy. See, so my now kinetic, where is the kinetic energy? This is my kinetic energy, right? This kinetic energy will now become, kinetic energy is half mv square at C. And this is now half m, what is v square? 2gh. This 2 and 2 cancels out, you get mgh. With this, I have proved one thing. Whatever was the, sorry, wait a minute. I have not proved it. Well, I left the proof, sorry. I left the proof, wait. Now, I need to show the total energy here. The total energy here. Total mechanical energy, total mechanical energy, total mechanical energy. Here, mechanical energy. This is kinetic energy plus potential energy. This is at C. So kinetic energy is, you can see, mgh plus 0 is equal to mgh. mgh. So whatever total energy was here, same total energy was at point B. You can see same total energy at point B, same total energy at point A. So all these came out to be same. So this is known as conservation of mechanical energy in a free falling body. I hope you got this point. This is quite important. At times they have asked, this question also has been asked once. Now let us define what power is all about. What is power all about? Let us define this quantity. Already, let me make it a bit bigger for you guys. Let me make it a bit bigger. Wait. Let me make it, yes, power. What is this power? You people have already seen in your smaller classes, you know, the rate of doing work is called power. You knew this. Let me write it down. The rate of doing work, rate of doing work is called power. Doing work is called power. And its unit is joule per second. Joule per second. That means that is called watt. W. Now, the thing is this, in your smaller classes, you have seen this formula. P is equal to WT. You have seen this formula. This is actually P average power. This was P average, which you have seen in your smaller classes. Already you have seen this. This is work upon time. Okay, now see one thing. I want to talk about instantaneous power. Instantaneous. Let me write it in short so that this big is not needed. INST. INST, instantaneous. It is dW by dt. Now W you already know. ddt of W you already know. That is F dot S vector. Now let this go inside. Now see, basically under the differentiation rule, it becomes df by dt dot s plus f dot ds dt under the rule of differentiation. But the point is that here F is constant. F is constant. F is constant. So df by, sorry, df by this df by dt vector is always zero. That means this quantity is always zero. So what are you left with? You are left with, you are left with P instantaneous, sorry, P instantaneous, inst, instantaneous is dw by dt, that is nothing but f. Now only this much is left because this quantity has become zero. So now you have f dot ds dt, and ds dt is nothing but v, f dot v. This is your power.